So today I'm going to work the solving systems quiz for you, the one that was on the board on the 11th day of February. Some of you guys had a sub, some of you did not. But this was the quiz that was on the board. We'll start with the first question. It says solve by substitution. Remember, substitution was our process that we decided to use 3 columns on to keep ourselves organized. And in the first column, we wanted to pick the equation that looked the easiest where we could solve for one of the variables, which meant to get it on a side by itself where it's positive. I notice here x and y are on the same side, and in this one, I already have x on a side by itself where it's positive, so I'm going to use that second equation in the first column. So I have x equals y plus 4 in the first column, and I know x is sub already, since it does have a variable on a side by itself where it's positive. Now that I've found the sub, I go to the second column. Whichever equation I didn't use in the first column, I use in the second one. So I'm going to start with x plus y equals 0. Now currently I have an x and a y in here, so it's very difficult to solve. But since I know x is sub, I can substitute in y plus 4 in place of x. So that's what we do next. We put in y plus 4 plus y equals 0. Now I go through using my solving equations flow map rules. So I don't have any parentheses. I do have like terms I can combine. So 1y plus 1y is 2y plus 4, which is equal to 0. I don't have variables on both sides. I do have a plus 4, so I'm going to subtract 4 from both sides. So I have 2y equals negative 4. And then I'm going to divide both sides by 2 to get rid of the multiply by 2. So I have y equals negative 2. At the end of the second column, I should have what the value is for y. And in this case, our value is negative 2. For the third column, you can use any of the original equations, or you can use your sub-equation, and I personally recommend using the sub-equation. So I have x equals y plus 4. Now that I know what y is, I sub it in place of y. So I have x equals negative 2 plus 4. Our signs are different, so we subtract the numbers. 4 minus 2 would give us 2. And we keep the sign of the larger absolute value. So absolute value of this one would be positive 4, so we're going to keep the positive. That means our coordinates are 2, negative 2 for our intersection point. That means we had intersecting lines. And when we have intersecting lines, that means we have one solution, which is what we got. We got 1 point, an x and a y coordinate point of 2, negative 2. For the next problem on the quiz, it asked us to solve by elimination, and they gave us 3x plus 7y equals 48, and 5x minus 7y equals negative 32. Remember, when we're solving by elimination, or as some people call it, addition, we are trying to add the two equations together in hopes that something is eliminated or cancel out. I'm looking now and I see that one of the y's is a negative 7y and the other one is a positive 7y. So if I added those together, they would cancel out. So I'm going to go ahead and add these two equations together. 3x plus 7y equals 48. And I'm going to add that to 5x minus 7y equals negative 32. If I add the x's together, I have 3x plus 5x, which is 8x. My positive 7y and my negative 7y canceled each other out. And then 48 and a negative 32. So that's like subtracting. So 8 minus 2 would be 6. 4 minus 3 would be 1. And it gets to keep a positive because our larger one was positive. Then we're going to divide both sides by 8. So we get x equals 2. Now that we know what x is, we can put it back into either of the original equations to be able to solve for y. So I'll just pick one. I'll use this one. It looks easier. There's no negatives in it. So 3x plus 7y equals 48. In place of x, I'm going to put in what I know x is equal to, which is 2. So I have 3 times 2 plus 7y equals 48. That's 6 plus 7y equals 48. Then I would subtract 6 from both sides. So I have 7y is equal to 42. Then we're going to divide both sides by 7. So y is equal to 6. This gives us an x and a y, which means we have an ordered pair. Our ordered pair is 2, 6. That means the type of lines we had were intersecting lines. We had one solution. So wherever those two lines were, something that looked like that, their intersection point was 2, 6. Last but not least, on your quiz, you were asked to solve a system using a matrix. So for our matrix, we need a calculator. We also need to know what matrix we're going to start with. So if I'm using these two equations, first I want to write down my information. So across this one, I would use 5, 7, negative 1. For this one, I would use 4, negative 2, and 22. Both of them were in standard form, and they were x, y, and then a number, x, y, and then a number, so I didn't get tricked by them being out of order or anything. Once I have my matrix, I go and set it up in my calculator. Remember, I go to second matrix, over to edit, I choose option 1. This has 2 rows and 3 columns, so it's a 2 by 3. The numbers I'm going to enter are 5, then I hit enter, 7, enter, negative 1, enter, 4, enter, negative 2, enter, 22, enter. Double check the numbers to make sure they're right. And then we quit out of it. We go back to second matrix, over to math. This is where we scroll down and pick up our math operation. We go down to RREF, hit enter. Now we have to go back and tell it which matrix to do that operation on. So we go to second matrix, option 1 for matrix A, and then we hit enter. The matrix that it shot back out for us was 1, 0, 4, 0, 1, negative 3. Remember all of our things in the first column that we put in were our x's. That's where the 4 and the 5 came from. So this is our x column. This is saying 1x is equal to 4. The second column was our y column. That's where these numbers came from, the 7 and the negative 2. So this is saying that this is 1y, which is equal to negative 3. So the ordered pair that it's giving us is 4, negative 3 for our x and y coordinates. So since we got one solution, these must have been intersecting lines. And when they are intersecting lines, they have only one solution. And this is the one solution that we got.